Right, here's a video on part 2 on forces and looking at the exam questions specifically. So the diagram shows the horizontal forces acting on the swimmer. The swimmer is moving at a constant speed. Force T is 120 newtons. You can see I've already labelled 120 newtons on there because it makes it easier to see what's happening. Now, so what is the size of force D? The key information here is it says he's moving at a constant speed. If you say he's moving at a constant speed, that means both forces must be equal on either side, giving a resultant force of 0 newtons, which means always you have a constant speed. It's a resultant force of 0 newtons because the difference between those two forces is 0. Okay, so we can say what is the size of force D? 120 newtons, because it must be the same as T. By increasing force T to 140 newtons, the swimmer accelerates to a higher speed. Calculate the size of the initial resultant force acting on the swimmer. So we can cross that out, and what happens is he swims harder and it gets to 140 newtons. So all we do is 140 newtons, take away 120, because that's what we knew we had on the back. That gives us a resultant force of 20 newtons, but to the left. 20 newtons left. Easy. Now this next one's not quite as easy. It's not super hard, but it's not easy either. Even though the swimmer keeps force T constant at 140 newtons, so I'm going to represent my swimmer as a little box like I showed you in the last one. It's 140 newtons that way, and then it's 120 newtons this way. Okay, the resultant force on the swimmer decreases to 0. So that means eventually that 120 newtons must increase to 140 newtons, so both are the same, to give the resultant force of 0. And this is the explanation for that. In this situation, as the swimmer swims harder and puts a larger force forwards, the swimmer's speed increases. So the speed of the swimmer increases as a result. Okay? This means water resistance will increase on swimmer, because when you swim you're having to push the water out of your way, and when you swim faster you're having to push the water out of the way faster, so that means more force is required to push it out of the way, and we call that force water resistance. Now if the water resistance increases, this force here starts to increase, and the faster you go the more it increases, until eventually both forces become equal. Okay, so water resistance will increase on the swimmer until it reaches 140 newtons, which means the resultant force equals 0, and swimmer double M will be at a constant speed. And that's your 3 marks. Okay, 1, 2, 3. Easy. So next question. An aeroplane is 4,000 meters above the Earth's surface. A skydiver jumps from the airplane and falls vertically. Figure 15 shows the distance the skydiver falls during the first 12 seconds. So you can see on the diagram, he accelerates at this point. Okay, we know he accelerates because it's getting steeper. So it's a steeper line. And we know if there's a steeper line, it's accelerating, it's speeding up. And at this point, it's moving at a constant speed. And we know it must be moving at a constant speed, so the forces acting on it must be equal. So if we draw the forces on the skydiver, remember, draw a square to represent it. At this point, the forces must be equal. Okay, so we draw arrows the same size. Down here, because it's accelerating, the forces on the skydiver, the force downwards must be greater than the force upwards. So as a result, that's what it looks like. And this is basically what this is saying down here. Okay, So if we look at this diagram, it says figure 16 shows part of a free body diagram for a skydiver 3 seconds after jumping. Complete the free body diagram for the skydiver. Okay, so 3 seconds after jumping is just here. And you can see at that point, at 3 seconds, he's accelerating. So if the skydiver is accelerating, the force downwards must be bigger. Now, it doesn't matter how much bigger as long as it is bigger. So you can see this is 3 squares. Okay, so I've done it as 4 squares. You could do it as 5, 6, 7 squares. Okay, and that's fine. You can see this is worth 2 marks. At the moment, you've only got 1. So what you need to do is write weight. You always must label the force with what kind of force it is. Now we know the size of the force because of the length of the arrow, and we know the direction of the force because of the direction in which the arrow is pointing. So as we said, weight is a vector because it has magnitude, so size and direction. So here's the final question. So the best way to do this is to imagine what's going to happen to the velocity of the skydiver or the speed of the skydiver as they fall. So I'm going to do the whole thing. The next question is just about the first bit. But we're going to have velocity there and time in there. And this is generally what a skydiver looks like, okay, as they fall. What happens to the velocity? It goes flat, and then it goes down, and it goes flat for a bit more, and it goes down and hits the ground. Okay, so what happens here is it's accelerating. And the reason why the skydiver is accelerating, they jump out the plane, and the skydiver has more force due to gravity than air resistance acting upwards. So that's our air, and that's our weight, okay, acting downwards. Now when we get up to here, eventually as the skydiver gets faster and faster, the air resistance increases because you're having to, the force of air resistance increases because you're having to force more air out the way. So at this point, eventually it becomes a constant speed. So at that point, both forces are equal. Okay, so our air resistance and our weight are equal. Then the skydiver opens the parachute, causes a huge increase in surface area, so air resistance is greater than the weight, which stays the same the whole time. Eventually the speed slows down, or the speed decreases, until we get to a point where air resistance isn't as great, because they're not having to push as much air out the way as quickly because the speed has decreased. So at this point, we've got the arrows the same again. We call these points terminal velocity. This is a faster terminal velocity up here, and it's a slower terminal velocity here. This is where both forces are equal, so we say the resultant forces are, or the resultant force is equal as well. Okay, so resultant force equals 0. It's the same up there as well. And then they hit the ground and they stop really quickly. And that's basically what happens in the skydive, and that shows you the forces of each one. Now, this question just here says, explain the change in motion of the skydiver in terms of forces acting on the skydiver. So they're only wanting this first little bit. They're only wanting it from there to there because that's all the graph showed on the previous one. Okay, so we've got a distance time graph here, but you could see it accelerates and then it goes at a constant speed. And then we've got a velocity time graph here that shows the same thing. It accelerates, then goes at a constant speed. So it says, explain the change in motion of the skydiver in terms of forces acting on the skydiver. So what we can say is, first of all, weight is greater than air resistance, so velocity or speed, you could say, increases. So here we've explained because we said that weight is greater than air resistance, so the velocity increases. Okay, we've explained the velocity increases because weight is greater than air resistance. Now, whenever we increase in velocity or speed, air resistance increases. So air resistance increases due to an increase in velocity. Because as we move faster, we're having to push more of the air out of the way quicker. Okay? Eventually, what happens is the air resistance increases to such an extent that it becomes the same as weight. So we say air resistance equals weight. So resultant force is 0. Okay. So sky diver falls at a constant speed, and we call that terminal velocity. Always mention terminal velocity, okay, because that will get you a mark. And that's it. Okay. Oh, sorry, you can't see that bit at the bottom there. It is terminal velocity. So whenever it's falling at a constant speed, call it terminal velocity. And then that's the 4 marks. Now, you might be asked why it slows down. So all you would say is that as the skydiver opens the parachute, okay, the surface area of the parachute increases. That causes air resistance to become much bigger than weight, so the speed decreases. As the speed decreases, the air resistance will decrease because you're not having to push as much air out the way as quickly, until it decreases, until it becomes the same as weight again, as you see here, and it moves at a slower constant velocity. But again, you don't need to explain that in this question, but you might need to in another question. Thank you.